Hello students, myself Dr. Isha Mehra from ABES Engineering College. Today we are going to discuss few formulas and numericals of lasers. So without any delay, let's start. The outlines of this presentation will be laser formulas and numericals related to it. So the first formula for laser, it will be energy of the laser pulse. E is equals to NH nu, where H is your Boltzmann constant and nu is your frequency of radiation. So let's start with the very easy numerical from this formula. Question number 1. In a ruby laser, total number of chromium ions, they are given. Total number of chromium ions, Cr3 plus ions, are 2.8 into 10 raised to the power 19. The wavelength of laser is given. Wavelength is 7,000 angstrom. So we have to calculate the energy of laser pulse. Calculate energy of laser pulse. It's easy. As we know, E is equals to NH nu. It's already written on the upper side. So we can easily solve this. E is equals to N is 2.8, 10 raised to the power 19. H is your constant. Its value will be 6.62 into 10 raised to the power minus 34. And frequency is not given, but wavelength is given. So we all know that nu is C by lambda. So it will be 3 into 10 raised to the power 8 by lambda. We can convert it into meter scale. So it will be 7,000 into 10 raised to the power minus 10. So that we can get the energy directly in joules. On solving this, we are going to get energy as 7.9 joules. So you can have a look. It's one of the easiest formula and easiest calculation. Only we have to find the energy of the laser pulse. Coming to the next question, let's change my slide. Question number 2. Calculate energy. Again, we have to calculate energy. Along with this, we have to calculate momentum also this time. Calculate energy and momentum of photon, which is having wavelength of 6328 angstrom. So again, the energy is given by E is equals to H nu. We can write this as Hc by lambda. So it will be 6.62 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8 by 6328 into 10 raised to the power minus 10. Because we have to convert this into meter scale, that is directly we have to calculate energy in joules. So it will be, the answer will be 3.14 into 10 raised to the power minus 19 joules. For momentum, P is equals to H by lambda. So again, on putting the values, it will be 6.62 into 10 raised to the power minus 34 by 6328 into 10 raised to the power minus 10, which will be 1.05 into 10 raised to the power minus 27. As it is momentum, the unit will be kg meter per second. So this time we are calculating energy as well as the momentum. Right? Coming to the next question. Question number 3. In a CO2 laser, now energy difference is given. Energy difference between two levels is given. Energy difference between two levels is 0.121 electron volt. So this time the energy is in electron volt. We have to calculate the frequency of radiation. So we have to calculate nu, frequency of radiation. So again we have nu as, we can write as this delta E, that is difference in energy by H. So this time nu will be 0.121. Convert this into joules, 1.6 into 10 raised to the power minus 19 divided by H, which is 6.62 into 10 raised to the power minus 34 per second. So the answer will be 0.029 into 10 raised to the power minus 15 per second. So this is the formula which we have used for calculating energy or frequency of radiation. There is one more formula, that is the population ratio. How we can find the population ratio? So the other formula is the population ratio, that is N2 by N1. Number of atoms in the upper state, upper lasing level, to the number of atoms in the lower lasing level, which is given by e raised to the power minus E2 minus E1 by KT. So let's do one simple question regarding this formula. Calculate the population ratio calculate population ratio, that is N2 by N1 we have to find, of two states in helium neon laser that produces light of wavelength 6,000 angstrom at temperature is given 300 Kelvin. So again, it's simple. We have N2 by N1 as e raised to the power minus h nu by kt, because E2 minus E1 is h nu. We can write this as minus h c by lambda kt. What is the value of K? I'm just writing it at the corner, 1.38 into 10 raised to the power minus 23 joules per Kelvin. So the solution will be e raised to the power minus 6.62 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8. Lambda is 6,000 into 10 raised to the power minus 10. Value of K will be 1.38 into 10 raised to the power minus 23, and temperature is 300 Kelvin. We have to make sure that the temperature should be in Kelvin. If it's in degrees Celsius, we have to convert it by addition of 273. So here the answer will be e raised to the power minus 80. E raised to the power minus 80. So this is how we are calculating population ratio. Now coming to the next question. This time in Ruby laser, we have two states. And what are those two states at 27 degrees Celsius and 227 degrees Celsius? So we have to convert this into Kelvin. If wavelength is given, if lambda is 7,000 angstrom, calculate relative population. Relative population here means first we have to calculate N2 by N1 at 27 degrees Celsius, and then we have to calculate N2 by N1 at 227 degrees Celsius. So it will be e raised to the power minus h c by lambda kt, which will be e raised to the power minus 6.62 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8. Lambda will be your 7,000 into 10 raised to the power minus 10. Value of K will be 1.38 into 10 raised to the power minus 34. We have to convert this temperature 27 degrees Celsius to Kelvin. So it will be 300 Kelvin. So the answer of first will be e raised to the power minus 69. Similarly, on solving the second part, which will be e raised to the power minus 6.62 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8 upon e, it will be 7,000 into 10 raised to the power minus 10, 1.38 into 10 raised to the power minus 34 into 227 will be added to 300, so it will be 500. So the answer will come out to be e raised to the power minus 41.1. So this is the other part, other formula which we have discussed. Now the other part which we are going to discuss is to find the intensity of laser beam, which is given by intensity is simple power of laser beam upon area. It is power of laser beam upon area P by A. So we are going to do a very simple question regarding this. It's very interesting and it's important for gate purpose also or other competitive exam also. So let's start. A laser beam can be focused on an area of 10 into 10 raised to the power minus 14 meters square. If laser emits energy at rate of 10 milliwatt, find intensity of laser beam. So simple intensity, as I have already told P by A. So it will be 10 into 10 raised to the power minus 3 upon area, which is 10 into 10 raised to the power minus 14. It will come out to be 10 raised to the power 11 watt per meter square. We are going to do one more question. Find the intensity of laser beam having power of 1 milliwatt and diameter is 1.4 mm. Then in this case, intensity will be P upon pi r square. So r is here 0.7 mm. So on calculating this, we are going to get 6.5 into 10 raised to the power 2 watt per meter square. So these are few numericals which we have done for laser. Now rest of the numericals we are going to do in the next presentation. These are the references which I have taken for numericals and formulas. Laser Fundamentals and Application by K. Tyagarajan Ajoy Ghatak, and Laser Applications, Laser Fundamentals by William T. Silfirst, University of Central Florida. So this is a disclaimer. Thank you. Thank you all.